So like Morpheus says, the matrix is all around us. Now we're going to mostly use matrices in this class to solve systems of equations like we were doing in chapter 3. Only once we learn how to do it, it's going to be really, really easy, and I think you're going to like it. But matrices were invented, as far as I know, as a mathematical tool to help deal with things like atoms and electrons, the very small, strange things that make up all the stuff all around us. Physicists who were studying these things around the beginning of the 20th century invented these mathematical tools we call matrices to help them to deal with this complexity. Matrices can also be used to scramble and decode secret messages, to describe geometrical transformations, and lots of other things. I hope that you're going to get to explore some of those in the project at the end of this unit. Alright, so to start off, we need to ask ourselves, what is the matrix? But unfortunately, the answer is not going to be quite as exciting as it is in the movie. Alright, a matrix for us in algebra class is basically a box of numbers, like these two guys. Matrix A, ooh, this is kind of weird. Matrix A has, as you can see, 2 rows and 3 columns. 2 rows. You see that? The top row and the bottom row. And 3 columns. The columns run vertically. So there's a column, there's a column, there's a column. And because it has 2 rows and 3 columns, we call it a 2 by 3 matrix. Okay, so matrix A is 2 by 3, and we write it with an X like that. 2 by 3. Okay? Matrix B is also a 2 by 3 matrix, 2 rows, 3 columns. That's just some vocabulary for you. Each individual number in the matrix is called an element or an entry in the matrix. So the entry or the element in the first row in the first column is a -2. The entry in the second row and the third column is an 8. Alright? So that's the basics of matrices. It's kind of like a table. Yeah? And one really, really easy thing that we can learn to do with matrices is to add them. Okay? A plus B. And I bet you guys could figure out how to do that without probably me saying very much. Probably what you would guess would be correct. I mean, A has these numbers in it, and B has these numbers in it. And what we're going to do is we're going to add the numbers. We're going to add the corresponding elements. So we're going to add the -2 to the 5, and we're going to get 3. And so in the result of A plus B, the element in the top row, the first row in the first column, is going to be a 3. -2 plus 5. So what do you think the element in the first row in the second column is going to be? The element that's going to go right here. Think about it for a minute. It's easy, right? It's 0 plus 7. Okay, so it's 7. What about the next one in that row, the last one in that row, A plus B? Well, it's going to be 0, right? 1 plus -1. And the bottom row works in the same way. 5 plus 0 gives us 5. 7 plus 2 gives us 9, and 8 plus -8 gives us 0. So that's the matrix A plus B, 3, 7, 0, 5, 9, 0. Okay, matrix addition, super duper easy. Alright, well, guess what? Matrix subtraction is just as easy. It's exactly the same thing. To subtract matrices, just like to add matrices, instead of adding, we're going to subtract the corresponding elements. So -2 minus 5, right? -2 minus 5, think about it for a second, that's going to give us -7, right? And the other elements follow the exact same pattern, 0 minus 7, so the next element is also a -7. What do you think the last element in the top row is going to be? Think about it for a minute. Watch out for the double negative. A minus B. 1 minus -1. That's right, 2. What about in the bottom row? 5 minus 0? See if you can figure out what the last two are going to be. Pause it for a second if you have to. Did you get it right? All we're doing is subtracting the corresponding elements, a minus b. Okay? So just like with normal numbers, matrices are basically a new kind of number. Okay? And they're complicated because this number b here has 6 pieces, and this number a has 6 pieces. But they're basically a new kind of number, and like normal numbers, it doesn't matter what order we add them in. If we added b plus a, we'd get the same thing, because all we're really doing is adding numbers. Also, like normal numbers, subtraction, the order does matter. If we subtracted numbers in the opposite order, well, we'd get the opposite thing. And the same is true with matrices. If I were to subtract b minus a, I'd have 7, 7, negative 2, negative 5, negative 5, negative 16, right? All the things would be negative, just like when you subtract numbers. If I subtract 1 minus 4 versus 4 minus 1, right? So they behave a lot like normal numbers. Okay. Matrix addition and subtraction, super duper easy. One last super duper easy thing before we get into more interesting things that we can do is we can multiply a matrix by a number. Okay, and again, this is going to do exactly what you think. We take A and we just make it 5 times bigger. So each entry is going to get 5 times bigger. This negative 2 is going to turn into a negative 10. This 0, well, 5 times 0 is still 0. This is going to become a 5, a 40, a 35, and a 25, right? Everybody's going to become 5 times bigger. This is called scalar multiplication, multiplying by a number. In the language of matrices, the word scalar, S-C-A-L-A-R, is sort of a derogatory term for a normal, simple, stupid number like 5. So this is scalar multiplication. I guess you could say that all we're doing is we're scaling the matrix up by a factor of 5. Instead of negative 2, 0, 1, we get negative 10, 0, 5. The bottom row also becomes 5 times bigger. And 5a looks like that. If you're thinking this is a challenge, you might want to try making something like negative 2b. See if you could do that and pause the movie and come back. But I bet it's really easy. You're just multiplying each element by that number. Okay. There's one really, really simple rule for when you can and when you cannot add and subtract matrices. Okay, you can add and subtract matrices only when the dimensions of the matrices are exactly the same. Okay, so we added and subtracted A and B, and that was fine because they both had dimension 2 by 3, 2 by 3. We can call that the dimension of the matrix. Okay, if those were any different from each other, we would not be able to add and subtract them. If we make a new matrix C, and this is going to end up being a really important matrix later on, called the identity matrix. But this matrix C, what's the dimensions of that matrix? It has how many rows and how many columns? Right, it's a 2 by 2 matrix because it has 2 rows and 2 columns. So even though it's similar, 2 by 2, 2 by 3, we can't add A plus C. It's kind of like dividing by 0. It's just not defined. It doesn't exist. We don't know what to do with it. Okay, and we can't add B plus C either. Multiplication of 2 matrices is different, and we're going to talk about that in the next piece of this first lecture. So now that you know what the matrix is, and you know some basic things about them, and how to add them and subtract them, and do scalar multiplication, you should be able to try your hand at these exercises on page 222. If you're just joining me, if you came from Miss Sonia's class, EOO, every other odd. So like 31, not 33, 35, not 37, 39, like that.